So, you've probably heard about cryptocurrencies. Bitcoin, Ethereum, the ones that go up and down like a roller coaster. One day you're rich, the next day, not so much. That volatility is exciting for traders, but for buying everyday things like a coffee or a new pair of sneakers, it's not exactly practical. Imagine buying a pizza for $20 worth of crypto, and by the time it's delivered, the value has dropped to $15. That's a problem that developers have been trying to solve for a while now. This is where a different kind of digital money comes into the picture, and it's called a stablecoin. The whole idea behind a stablecoin is right there in the name, stability. It's a type of cryptocurrency that's designed to have a fixed price. Most stablecoins try to peg their value to something real, like the US dollar. So one stablecoin might always be worth exactly $1. Now, a new player is entering the game, and it's called Pi. But this isn't your average stablecoin aiming for a simple $1 peg. The team behind the Pi network is aiming for something much, much bigger. They are launching a stablecoin with a target value of $314,159 for a single Pi. I know, that number sounds wild, and it's a huge claim. The goal here isn't just to create a stable currency, but to establish a high-value digital asset from the get-go. They believe this can create a new kind of digital economy from the ground up, one where the currency has significant purchasing power from its very first day of trading. The big question, of course, is how. How can anyone just decide a new currency is worth over $300,000 and make it stick? It's not as simple as just saying it. To achieve this ambitious goal, the Pi network is using a combination of brand new technology and some interesting new regulations. To understand how Pi plans to pull this off, we first need to talk about a new piece of legislation that's shaking things up. It's called the Global Economic Nexus and Unified Security Act, or the Genius Act for short. Now, governments have been trying to figure out how to handle crypto for years. It's a tricky subject. They want to encourage innovation, protect consumers, prevent illegal activities. The Genius Act is a new framework designed to do exactly that. It sets out a clear path for new digital currencies to be recognized as legitimate financial tools, but only if they follow some very specific rules. Think of the Genius Act as a rulebook for creating new, trustworthy digital money. It basically says that if a new cryptocurrency wants to be treated like real money, it needs to prove that it's stable, secure, transparent. One of the key requirements is that the currency must have a built-in mechanism to control its value. It can't just be based on pure speculation and hype. The act requires a verifiable price stability mechanism. The entire architecture of the PI stablecoin has been designed from the ground up to meet the requirements of the Genius Act. By complying with these new regulations, PI isn't just another crypto project launching into the wild west of the internet. Instead, it's positioning itself as a fully compliant, government-recognized form of digital currency. This legal backing is a huge deal. It gives the project a level of legitimacy that most other cryptocurrencies just don't have. It's like getting a seal of approval that tells users and businesses, hey, this thing is built to last. So, the Genius Act is essentially the legal backbone that supports PI's ambitious valuation. It provides the regulatory framework that allows a system designed for high-value stability to exist. Without it, the claim of $314,159 would be much harder for the mainstream to take seriously. By building to fit these rules, Pi signals they're here to be a stable, high-value currency for the global economy, and they have the legal playbook to do it. Alright, so we have the legal framework with the Genius Act. Now let's get into the tech that makes it all work. The foundation of almost any decentralized network is something called a node. A node is essentially just a computer that is connected to the network and helps run it. It can be anyone's computer, yours, mine, a big company's server. Each node keeps a copy of the network's public ledger, the official record of all transactions. Think of it as a shared digital notebook everyone has a copy of. When a transaction happens, someone sends Pi to a friend, that transaction is broadcast to all the nodes. Nodes work together to verify it's legitimate. They check. Does the sender have enough PI? They check. Is the digital signature valid? Once enough nodes agree, the transaction is added to the official ledger. Group verification is what makes the network secure. There's no single person or company who could cheat the system. Power is distributed among all the nodes. With thousands or even millions of nodes holding the same ledger, it's nearly impossible for a bad actor to alter it. While regular nodes are essential for maintaining the basic security of the network, the Pi network introduces another, more powerful layer, the supernodes. If a regular node is like a security guard checking IDs at the door, A supernode is like the central security office that monitors all the cameras and coordinates everything. Supernodes are computers with more power, faster internet connections, and a proven track record of reliability on the network. They take on extra responsibilities and are critical for the network's advanced functions. They act as major hubs, routing data quickly across the globe, helping Pi process transactions faster. You can't wait 10 minutes for a payment. Most importantly, supernodes interact with smart contracts and with oracles to monitor real-world data and execute automated rules designed to keep Pi pegged at $314,159. Fewer supernodes, higher standards, they form a trusted council for critical tasks. In short, supernodes are the heavy lifters, providing speed, reliability, and computational power. They don't replace regular nodes, they work with them. Regular nodes provide broad, decentralized security. Supernodes provide the high-performance backbone for complex operations. So we have nodes for security and supernodes for performance. But how does the network know what's happening in the real world? Oracles. An oracle is a service that finds and verifies real-world data and brings it onto the blockchain so it can be used in smart contracts. Think of it like this. A blockchain is like a person locked in a soundproof room. An oracle is the trusted messenger who looks outside, sees it's raining, and reports back. For Pi, oracles monitor trading value across exchanges and marketplaces, pulling data from many sources, cross-referencing, and reaching consensus on the true market price. They feed that data to smart contracts. Without oracles, the whole stability mechanism would be flying blind. The system needs reliable, real-time information to manage supply and maintain the target price. If the oracles report a dip below 314,159, the system takes action. If they report the price is creeping above the target, it does something else. These oracles are the eyes and ears, providing the stream that lets automation steer and keep price where it needs to be. We've got the nodes, the supernodes, and the oracles feeding them data. This is where the real magic happens with smart contracts. A smart contract is a program on the blockchain that automatically executes when conditions are met. It's like a vending machine. You meet the condition, you get the outcome. No cashier needed. These contracts are the brains behind Pi stability. Pre-written rules on-chain, immutable, autonomous, listening to oracle price feeds. If the price drops below 314,159, buy. If it rises above, mint and sell from stabilization reserves to bring price back to the peg. So, let's walk through the entire process step by step. It all starts with you, the user, wanting to buy or sell Pi on an exchange. Every transaction is broadcast across the network. Thousands of regular nodes verify it and add it to the shared public ledger. This ensures integrity. No one can spend money they don't have. Meanwhile, oracles monitor Pi prices across exchanges, gather data, and compute a reliable average. If selling pressure dips the price to 314,150, oracles alert the main stability contract. The contract checks. Price, 314,159. Initiate buyback. It sends orders to supernodes. Supernodes access the capital reserve vault and start buying Pi where prices are lowest, creating buying pressure. As circulating supply drops, scarcity increases and price moves back toward the target. Oracles confirm the peg. The contract halts the intervention. If price rises above the peg, the contract mints from reserve and sells, increasing supply to bring price down. This constant, automated cycle of monitoring and adjusting is how the Pi stablecoin maintains its ambitious and unwavering value. It's like cruise control. Oracles are sensors, smart contracts the ECU. Uphill, it buys. Downhill, it sells. The goal, hold steady at 314,159. So after all this tech talk, nodes, oracles, smart contracts, you might be wondering, what does this actually mean for me? Why should an everyday person get excited about a stablecoin like Pi? It can make your money more powerful and useful. Digital currency that doesn't lose value overnight, recognized globally, sent to anyone, settles in seconds, almost no fees. The high-value peg, 314,159, means you deal in fractions of a single PI. Buying a car might be 0.127 PI. It could simplify global trade and make high-value assets more accessible. Transfers cross borders without conversion fees or bank holidays. A new app ecosystem enables microtransactions and peer-to-peer economies. Earn meaningful fractions of PI for contributions. It's ambitious and has hurdles, but if it works, it could enable financial inclusion and create a more efficient, transparent, equitable global economy. It's about rethinking what money can be, who it can work for, and that's a future worth paying attention to.